G'day, Mike. How you doing this morning?
I'm pretty well, Andrew. How are you?
Yeah, I'm doing well, mate. I'm doing well.
I'm excited to
Excited
be
to
here.
be here at Shipped. Yep. Today we're going to present a talk together called Save a Canary, Flip a Toggle. And the 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 story is about the evolution of our delivery pipeline. So we operate Octopus Cloud, right? We ship CD features to thousands of customers all the day after day. And over the years, our approach to rolling features out to our customers has changed quite a lot, and it's evolved along with our products. And that's evolution is really what we're here to talk about today, right? We'll talk a
Indeed.
bit about our design decisions, some of our key learnings, and ultimately we'll talk about why we built Octopus Feature Toggles. So my name's Andrew Best. I'm a senior principal engineer here at Octopus. I work in our foundations group. How about you, Mike? I might hand over to you now.
Yeah, thank you. My name's Michael Richardson. I'm a product director at Octopus. I live in what we call our deploy group. We build a bunch of the CD type functionality. Should we dive in?
Yeah, let's go. How should we get started today, Mike?
Well, I reckon we start with the punchline. Let's cut to the chase, as they say in the movies. So we're going to start by releasing an actual feature, just like we would on any given day, to show you what it looks like for us when we ship features to Octopus Deploy. So with that, I'm going to jump to here. And so this is our internal Octopus instance. This is what we see. This is what ships Octopus server that you use. And today, we're going to dive in here. And you might notice there's a new tab on here that you may not have seen before called Feature Toggles. And we're going to jump in here. The feature that we're going to release today is a feature called Project Templates. This is not at all the topic of our talk, but in the spirit of never missing an opportunity to be pitching, I'll give you the quick 10-second overview. Project Templates is part of our Platform Hub offering. It will be when we release it sometime next year. And it's designed to allow you to standardize entire Octopus projects. So if you have 50 microservices that all look exactly the same and you want to ship in the same way, you'll be able to base them all on the same template, and you'll be able to receive updates to that template. And yeah, it makes onboarding new teams as simple as a few button clicks, and they'll be up and deploying. Really cool feature. But
It's pretty
like I said,
exciting.
it is really exciting, but it's not at all the topic for today. Today, what we're going to do is release this feature. So it's in development at the moment. So it's hidden behind a feature toggle, which is how we build things. And I am going to ship it to my internal Octopus instance. Well, when I say internal, it's actually a production instance, just like any other one. It just happens to be my instance. And so I'm toggling this feature on for that. Before I do that, I should show you there's nothing up my sleeve here. So this is this instance. You see I'm in Platform Hub, and you'll see we've got process templates, we've got policies, which is lovely. But what I really want is some project templates. So let's ship it. That is done. And if we jump over here now and refresh, project templates. Ta-da, simple as
That
that.
was so easy. That's so
So
easy.
easy, right? I will jump back to my slides here. Sorry, got windows everywhere. And yeah, so that is how we ship a feature. And so that's very similar to what we will do when we come to ship this for real to our customers. We might roll it out to 5% of them first, but we're going to talk a little bit about that coming up. But yeah, that's it. Lovely,
Was
amazing, right?
was it always that easy, Mike? Has shipping just been, just flick a toggle and all of our customers get great new stuff?
Right. So this is where we need the big record scratch sound effect, don't we, John? Can we add that in post-production, please? A big because no, it definitely wasn't always this way. The purpose of today's talk actually isn't for us to brag about our release process. Like everyone, we very much consider it a work in progress. What we want to talk today about is our journey towards that progressive delivery. And so there are two major components to progressive delivery. One of those is canary deployments. The other one is feature toggles. And we're going to talk about the various iterations that we've gone through of both canary deployments and our feature toggles offering, and why we decided to build feature toggles as a feature in Octopus. And with that, I'll hand back to you, Andrew.
Yeah, cool. Cool. Let's go on a bit of a journey here, and we'll start talking about the early days, where we were before. So, flick the next slide, Mike. So Octopus started life many years ago as a self-hosted product. This little purple guy here was our logo many moons ago. Mike, you were around when this guy was our logo, weren't you?
Oh, come on, I haven't been here that long, no.
Our art skills have evolved along with our products over time. And this was also, so it was a simpler time for our logos. It was a simpler time for our delivery pipeline too. So engineers would merge features from feature branches. They would work on them until they were satisfied. They would merge them into main. Our delivery pipeline would kick in, and within an hour or two, those features would be available on our website for all of our customers to download and install. And that was basically it. It was very straightforward. And this worked really well for a time, right? We could put new features into customer hands really quickly when we needed to. We could be agile, we could be fast, we'd ship early and often. It's a great way to evolve a product. Now, some time passed and Octopus became a bit more complex, started adding sort of more features to it. And the product grew in capability and complexity. And as it did, we started encountering more quality issues, as you do when software becomes more complex. So we had this sort of climbing change failure rate that we were trying to deal with. And when our customers encountered issues, time to recovery was something that we would struggle with from time to time, because the nature of self-hosted software is we're not in control of that last mile of the delivery pipeline, right? The software is up on our website, but it's really up to our customers to download and install it and to manage the actual sort of deployment of the software into their environment. And so time to recovery at times was not something we were satisfied with. It could be, it was beyond what we were comfortable with, and so it was growing as well. And so the combination of these two things were becoming a bit painful. We were longing for more safety and control in our delivery pipeline. And fast forward a little bit, then comes Octopus Cloud. And it seemed logical to us at the time that we would use our cloud product to improve our product quality and to help solve this problem. And we'd do so by shifting to a progressive delivery model. It's important to understand in the architecture of Octopus Cloud, every customer gets their own isolated Octopus instance, which is great from a product perspective. It gives our customers a number of benefits as to sort of the isolation of their instance and the protection of their data and things like this. But it sure does make deployments a bit more challenging, because you're not just deploying one thing that all of your customers inhabit, you're deploying thousands of things, and all of your customers inhabit those. And so in this new progressive delivery model that we'd imagined, we'd first deploy to ourselves and our team, our inside instances. You saw Mike's instance before as a good example of sort of insider instances that we have. We deployed to some early adopters that we had, and then eventually the changes would make themselves out into the broadest environments where all of the rest of our customers were, and then into self-hosted. Conceptually, we pictured this as a set of rings like you see here. We called them cloud rings, and these were modeled as environments in Octopus ultimately. And each ring would bake for a short period of time. And the model might be very familiar to some. We could call these cloud rings canary rings, and it would be very similar in the concept. The idea is we deploy a set of changes to fewer customers to start with. We give it a little bit of time to see if we can get signal as to whether the quality of those changes is sufficient. And once we're satisfied that it is, we propagate those changes to downstream, higher impact, more populated environments. And so if something does go wrong, we catch it early, less people are impacted, we can fix it really quickly, and we can get on with life. And a new release will go out the door. So that was the hypothesis. Letting changes bake for short periods in these canary environments would let us catch these bugs earlier. We would reduce change failure, and we would drastically reduce mean time to recovery. That was
Makes sense to me.
after. Yeah, that was the idea. And so what we've got here is what we ended up with in Octopus. This is once again is a snapshot of our Octopus server deployment dashboard here. And at the very left, we have some automated testing environments. And then once we get to production, we start this process of baking changes in these rings, these concentric rings or environments in Octopus, until eventually the changes go out the door to GA, which is our self-hosted environment. And this is where it might look a little different from your typical sort of Facebook style canary deployment. Now, Octopus doesn't enjoy the level of traffic Facebook or Google does, right? Your average Octopus instance, right, Mike?
I wish we did. Yeah, one day.
Yeah, it would make our lives much easier, but it doesn't. We can't deploy changes for 30 seconds and generate sufficient signal that those changes are healthy or not and decide on that whether to roll back or forward. So we need to wait. Our hypothesis is that we needed to wait a little while. We needed to give the software time to be adequately utilized in one of these canary environments before we would propagate it onto the downstream higher impact environments. So we get some signal as to whether it was healthy or not. So we would bake these changes for 24 hours on our own production instance, and then for a few days on our staff instances like Mike's, 7 days in early adopters, and then they would be out the door to everyone else. And to make this happen, we needed to develop a few specialized components that would complement our sort of core capabilities in Octopus and allow us to achieve this delivery model. So the first of these components is a thing called the enthusiastic promoter.
I love this name.
Yeah, it's good, isn't it? So the idea behind the enthusiastic promoter is that as soon as a change hits main, if everything goes well, it should make its way out the door to all of our customers without a set of human hands touching it. So it's the thing that allows us to make our progressive delivery continuous delivery. And the promoter itself is just a small CLI tool. It's a .NET tool that we built that promotes releases as long as a set of criteria is satisfied. And these criteria are things like, is there a newer release I should be promoting? Is there an open issue with this release and should I not be promoting it? Is it the weekend? Is Mike on call at the moment? Can we deploy these changes now? It's kind of like life cycles on steroids. It's tailored to suit our particular business rules and needs. It'd actually be really neat if some of these things we're presenting today make their way back into the products. And it's pretty typical, right, Mike? We do this a bit.
Yeah, absolutely. We often see this. We sort of write something that fills a gap and eventually it becomes a product feature, like we're about to see actually with feature toggles.
Yeah. So we run this CLI tool in a runbook. The runbook runs every 5 minutes and it decides whether it should promote the release onto the next downstream environment if it's ready to go. Now, when we have this enthusiastic promoter or this enthusiastic machine that wants to progress changes along continuously to all of our customers, occasionally something might go wrong. And when it does, we need to be able to stop that machine. And the reason we want to stop the machine is so that we can do investigation and remediation when we need to, in like a
We need to
calm
dampen
and
its
ordered.
enthusiasm a little bit.
Yeah, that's it.
Yeah.
I think at some point we were thinking about renaming it the cautious promoter to sort of to infer that. But anyway, the end-on cord, the idea behind this system was that when you pull the cord, the enthusiastic promoter stops. So anyone in the company can pull this cord. It's a well-known system. You can go to it, you hit a button, and the machine stops essentially. And there's a message that goes into Slack, and everyone gets a bit of a chance to breathe, deal with the problem, investigate what it is. And if something is actually wrong and we need to go and remediate it, we need to patch or bug fix or do something, then we can also taint a set of releases to say, hey, the enthusiastic promoter should not promote this set of releases because they contain a defect and we've patched it here. But this set here shouldn't go out the door. So it plays sort of two critical roles there. And the final thing in our list was feature toggles. But this wasn't the awesome auto on suite feature toggles Mike demoed before. These were the feature toggles that many teams start with when you're building software. They're basic code constructs that are driven by environment variables in the host environment. And so this allowed us to toggle features on and off in our application. But the downside to them is we needed to restart customer instances for them to take effect because we wanted them to remain stable for the lifetime of the process. And we could only restart customer instances in our cloud environment when there was a scheduled outage window. And the reason for that is we don't like interrupting customer deployments. You know, deployments are not CI, right, Mike? We can't just kill deployments like you can kill builds.
No, not quite as immutable as a build, unfortunately.
Yeah, the last thing you want to do is to kill a deployment when it's halfway through thousands of tenants and have to sort of reconcile the state of the world at that point. It's a bad time.
Absolutely.
Bad time. So we value that uptime highly. We don't want that interruption. Given this, they weren't widely adopted by teams because teams would generally preference just patching and rolling forward, because what ended up happening was, since you had to wait for the customer outage window anyway, the mean time to recovery between patching or toggling the feature was about the same, and people just ended up preferencing it. It's not the bug fix that usually takes the time, it's the investigation. The bug fix is pretty quick to apply and then to roll out. So we usually ended up just patching and rolling forward. And at this point, you might think, well, aren't we talking about canary environments here? Shouldn't we be doing rollbacks when we detect issues? Rollbacks are challenging in software that deals with databases or any type of state. As soon as you deploy a new version of software that changes the way that your state is stored or expected to be, rolling back to a previous version that expects your state to be in a different shape is actually a really challenging thing to do. And there's patterns that allow you to do it, but at Octopus, we've made a conscious choice not to incur that cost and instead to lean into rolling forward to fix issues. So we developed this set of specialized tools and we had this hypothesis, and what we thought we were going to get was a modest increase in chase lean time, because as we said, we had these canary environments, but due to the nature of our software, we also had to let it bake for a little while in each of these environments before it propagated out. And what we'd hoped to see was a drastically reduced change failure rate and time to recovery. Particularly the time to recovery here is important. We thought, hey, we're going to catch issues really early, we're going to fix them, and then we're going to roll out new versions of the software that have been corrected that won't have those issues in them. So by the time it gets out to all of our customers, we'll have a much higher quality product.
This is going to be a short presentation if the next slide says this is exactly what we got and we're done.
Yeah, that's right. And everything was great, and yeah,
we can all go home.
Yeah, that would have been ideal. However, that is not what we got. What we actually got was a substantially increased lead time for reasons I'll go into on the next slide. But it's also questionable as to whether we derived any benefit as far as change failure rate and time to recovery goes. And the reason for this was what ended up happening, what we found after running this pipeline for 6 to 12 months, was we either hit problems straight away, and we found them as soon as they hit our internal instance. It was like, hey, this thing is off and we need to fix it. Or we found the problem once it had rolled out to all of our customers. And there was almost 0 times we would catch these issues when the software was sitting in these canary rings or these canary environments. And on reflection, it's kind of a reflection of our software. This is, if you can hold Octopus in a lot of ways, right, Mike? It's really powerful and flexible. And so quality issues surface in unpredictable ways. Sometimes you actually have to deploy the software out to a very large cohort of customers, and for it to hit the customers who's holding Octopus in a very specific way, for a quality issue to the surface, and for you to then know that you've got a bug to deal with, just in case it hits other customers as well.
It's also a fundamental thing where our biggest, most risky customers are right at the end of that rollout pipeline as well, because they're also the ones that we don't want to hit with the early rings.
Yeah, right. But it turns out they're the ones that encounter these problems because they have such sophisticated and complex deployment environments. They just, they've got gnarly complexions of how they hold Octopus's features. So, what was going wrong? This is a bit of a complex picture, but I'll try and walk us through it. So at the bottom here, we've introduced a change, this red bar, that contains a defect. And it's rolling out the door from PR merged across the x-axis here. It gets deployed to our staff instances, early adopters, stable. as it's rolling out along that x-axis, we're accumulating new features on the y-axis, right? We don't stop building software just because we're shipping something out. We keep integrating new features into main, and they start baking and working their way through the environments as well. And then 11, 12 days later, once it hits all of our customers in our sort of cloud customer environment, we find a defect and the core gets pulled. We investigate it, we issue a patch, we deploy the patch right out to everyone. The patch only contains the bug fix. It doesn't contain any of these new features. What happens then, although, I mean, it took us a very long time to find this bug, which is one problem, but what happens after this is the big problem. Now, we've got this big batch of changes here. It's about 10 days worth of PRs. We were shipping at this time in 2023 about 10, every 10 days, we'd ship about 100 PRs, Mike. And so you had 100 PRs worth of changes that all of a sudden, they contain the same defect, right? They're not sitting there on isolated branches. We practice continuous integration. And so, they've all got the same defect. So we have to stop propagating those and then issue a new release that contain the bug fix and all of these new features. And guess what happens once that big batch of features reaches our biggest customers?
It's higher risk. It's got a whole bunch of changes in it.
That's right. It might have another defect. And when that happens, you go through the same cycle again and it compounds. And sometimes you end up with embarrassingly long lead times, like quite bad.
So the irony here is that we implemented progressive delivery hoping to get smaller batch sizes, and what we actually ended up getting was effectively larger batch sizes to the later environments.
Sometimes much, much larger, yes. So the hypothesis completely fell through, and we were almost getting the opposite of what we had hoped to get out of this setup. So what needed to change? Now, there was a point here where we were getting this feedback, and it was developers were expressing that they were dissatisfied with, like, why is it taking my changes so long to get out to customers? But it was actually quite challenging to point out what the specific problem was. And we had to go and crunch a bunch of data so that we could point at this fact that where we were catching bugs and we were getting no value from these canary rings, right? And so we needed to simplify it. The canaries, as we'd structured them, they weren't working for us. We needed to remove these cloud rings, still have some progressive delivery, but drastically shorten that lead time. And then we would tighten up that mean time to recovery, shrink batch sizes, shrink change failure rate, shrink lead time, and everyone would be a lot happier. And this brings us to this somewhat counterintuitive point here where going faster will improve product quality. Now, this is something when we propose this change. So we've got this internal process at Octopus where we issue written RFCs when we're going to make significant changes to our product or our delivery pipeline or our processes, and it allows you to gather a lot of feedback across across our organization as to whether people are on board with the change and whether things need to be different. And what we actually found that even though the delivery pipeline was causing a lot of pain, a lot of people were really worried about removing those canary rings, weren't they, Mike?
Yeah, I think without the data to back this, it seems quite contentious, right? We're taking away safety nets.
People were like, that's what keeps us safe, right? That's where we catch bugs. But it wasn't like this. It wasn't at all. And so we needed to move to shipping smaller batches more frequently. It also means the whole diagnosis and recovery process is simpler, right? Smaller batches, it's much easier to bisect the changes that are in there, figure out the change that introduced the defect, fix it, move on, we're happy. So our data backed up this change 100%, and we needed to move on.
Our canary environments weren't paying for themselves, basically. They weren't justifying the complexity of being there.
Yeah, absolutely not. They were not pulling their weight. So we made this new proposal. We're going to go faster. But you remember, if we zoom right back to the start, we were moving fast, right? And we had this other problem. We lacked safety and control when we were deploying changes down. We didn't want to sort of take 2 steps back and end up where we began with. We wanted to move forward, wanted to roll forward, so to speak. So we wanted to move fast, improve product quality. But when there's issues, that do arise, we want to control them so that we can intervene, recover quickly with calm and order. How do we do this? We decouple deployment from release. So what we want to do is we want to deploy fast and often. We want features to keep, the enthusiastic promoter to do its job and keep shunting software changes out the door and then getting deployed to customer instances. But then the flow of releases, of feature release, is controlled by humans, like Mike demonstrated before. Once we're ready and we know the software is in a particular state, we hit a toggle, the feature turns on, we look at our observability, we understand whether it's healthy or not. And in this way, rather than like 2 customers or a handful of customers using the software and us trying to get insight from that, it would be rolled out potentially to all of our customers or quite a lot of them. And we'd have a lot more chance when we turn the feature on of diagnosing a potential problem, reverting, flicking off a feature toggle and being able to intervene. Now, we developed Octopus Feature Toggles to solve this. And they're also complemented by the and-on cord still. So it's important that we can still pull the cord and stop the enthusiastic machine and investigate the problem. So you don't just flick a toggle off. It's a poor customer experience for things to appear and disappear in the middle of them being used. But what we want to be able to do is stop the machine, do some investigation, and if the remediation is, we can just flick a toggle off and that'll recover and we'll go solve the problem, at our leisure afterwards. That's the best, that's how we want to recover from problems. That's ideal. So these 2 systems are really complementary. Now, and so at the end of the day, we developed Octopus Feature Toggles. They take effect instantly when they're toggled, and we can recover in seconds instead of hours or days. Now, Mike, do you want to talk now a bit about where we are today?
Yeah, absolutely. So yeah, let's time shift back to now. John, can we have the time travel sound effect, please? We showed a little demo at the beginning of how we release features today, and let's drill into a little bit more of what's behind that. So there's a bit of a recap. Where are we today? As Bestie was explaining, we've collapsed our, I guess you could think of them as canary rings down. So the way we ship today, we release internally to our internal instances. This is our dog food environment. We then, after a couple of days there, we progress this to our Octopus Cloud customers. And we initially ship to 5% initially. That's our first canary ring. And then, again, we let it bake for a couple of days, and we ship to then 100% of Octopus Cloud customers. And at some point in the future, assuming that's stable, we eventually cut a self-hosted release. So notice that that's a truncated version of the canary rings that Andrew showed on an earlier slide. And am I correct in saying, Bessie, that we're considering collapsing this even further?
Yeah, we're getting signal, after we've had this shortened model for some time now, that we think we can cut these canary bake times in half again, and we likely still get all of the value we get out of those canary rings. Now that we have sort of the feature toggles there to control the impact of the flow of changes, and we've decoupled that deployment and release, we're pretty comfortable with really sort of shortening that lead time and shipping really quickly.
I love the fact that we're optimizing this basically based on data, right? We're just checking what's the optimal here, the optimal amount of bake time to catch the majority of the errors. So this is an automated process. This will happen with no human involvement. So you used the phrase humans in the loop earlier, and we have 2 places where humans are in the loop. One is this and-on cord down here. So if at any point somebody detects an issue along the way, we can pull that and-on cord, and that will prevent that release from continuing to roll out until the issue is resolved. The second place where we have humans in the loop is these feature toggles. And as Bestie mentioned, we've moved from our internal home rolled feature toggle system to something that we're actually going to build into the product. And that's what I want to talk a little bit about now. So why did we build Octopus Feature Toggles? This definitely wasn't our first instinct. We initially built a very simple environment variable-based toggling system, similar, I suspect, to what many of you have either built yourselves or used at places that you've worked. But as we said, this actually didn't give us what we needed. Most notably, if we found an error and had to roll it back, so toggle the feature off, we still had to restart that Octopus instance, which completely blew out the time to recovery on those issues. defeating the purpose of having the feature toggles. And so we also looked at some off-the-shelf feature toggling systems, so commercial products, to be able to do this. Again, they didn't quite fit our use case, and mostly that's because they didn't have that knowledge of Octopus environments and tenants baked into them, because this is how we ship. It makes sense, right? So the final point was, from a product vision point of view, we've always felt that feature toggles are a core part of continuous delivery. We rely on them very heavily, and we want to advocate for them as part of a continuous delivery pipeline. And we think they're a really natural fit in Octopus as well. And so we built it.
I think just sort of adding to that point about the commercial solutions, Mike, what we found was a lot of them end up wanting to toggle on features in a very user-centric way, right? Like they want to turn them on for cohorts of users, or users who are matching particular,
Yes.
patterns or labels that you can attribute to them through your software. And we don't really do that in our delivery pipeline. We want to turn on features for our customers. And it doesn't make a lot of sense to turn on features for percentages of users within our customers. We just want
No,
to turn it
you're
on
right.
for a customer, or turn it off for a customer.
Yeah, and I suspect people watching may have the same situations. Like for us, Octopus is a collaboration tool. It makes no sense to enable a feature for one user if the other user in their team can't also see that feature as well. It's also an automation tool. It makes no sense for one user to see a feature that then results in a workflow that no one else can understand how that workflow is configured, for example. So it's very much account or license-based rollout for us. So I thought I'd show you this slide because I think it does this screenshot is configuring a feature toggle, an Octopus feature toggle, and it shows just how deeply embedded they are with the Octopus ecosystem. So you can see you toggle a feature on and off for an environment, which hopefully makes a fair bit of sense. But the other really an interesting point that we've learned, and customers as well, is that often you want to toggle a feature toggle on, but only to take effect once a environment. So the classic example here is there's an issue with the feature, so you toggle it off, you ship a fix for that. You want to toggle that feature back on, but you only want that to take effect once the release version that contains the fix hits that environment. Otherwise, you're just re-enabling the feature with the same bug in it originally, or someone has to sit there and watch that release progress through the environments and time the feature toggle. It's much easier just to be able to say, toggle this back on for this release version. And of course, Octopus knows intimately about releases, so this is really natural. You can also see here, you can absolutely configure feature toggles for tenants. So you can turn a feature on for specific tenants, exclude it from specific tenants, which is really interesting as well, and even roll it out to a percentage of tenants, which is exactly what we do and how we ship. The other thing, the decision that I think in hindsight we're really happy with as well, is we based Octopus Feature Toggles on a library called OpenFeature. If you haven't seen this before, I definitely recommend you check it out. This is a CNCF project. It's an open specification, as the text here says, that provides a vendor-agnostic, community-driven API for feature flagging. The mental model here, think open telemetry, but for feature toggles, basically. And the advantage for us is that we get a well thought through designed SDK that has clients for all the popular programming languages, Java, .NET, Go, TypeScript, just about anything else you can think of. The advantage for you as consumers is you get no vendor lock-in. So I'll show you actually on the next slide here. This is what it looks like from I guess a conceptual point of view. So your evaluations in your code take place against the OpenFeature SDK, and you just configure the actual feature toggle provider as a provider model in that. So in this little code sample here, it says your provider of choice. In reality, you would use Octopus feature toggles there, or Launch Darkly, or your own home rolled system, whatever you have. And what that means is that if you, say, start with Octopus for your feature toggling needs, and at some point in the future you decide you need a more fully featured feature toggle service, swapping over to that becomes as simple literally as one line of code change, so the rest of your application isn't tightly bound to the provider, which I think is lovely. So I think it's time for a little bit of a summary here. So what have we got now? You saw the journey over time. We went basically from a very short change lead time when we would effectively YOLO changes into production. We implemented from there a whole lot of canary rings and drastically increased that lead time. Where we've landed at the moment is we've accepted a moderate increase in the change lead time. We still have canary rings there, as you saw. We have some bake time. And we've I guess achieved a moderate reduction in the change failure rate as well, because depending on how you measure it, progressive deployments don't actually necessarily prevent failures. They are just a mechanism to be able to recover from them quickly. And that's the big thing that we've gained here, is we've gained a fast time to recovery. With using Octopus Feature Toggles, we can now toggle features on and off instantly. So errors and defects ultimately will happen, but the important thing is how you can recover from them, because this is what actually limits the number of users that experience any of those issues. Right,
Yeah,
Bestie?
that's the big thing, right? Like it's the whole if a tree falls in the woods and no one's around to hear it, does it make a sound? Like if a defect happens, but very few customers experience it, does it, is the impact that great? So it's that time to
Exactly.
recovery that's really essential.
And with that, I think we'll talk about a few of the key takeaways that we've learned on this journey and hopefully are applicable for you as well. I think the first is that, as much as it's challenging, progressive delivery is actually a win. It improves the experience for your customers and for your team's shipping. Our customers experience less errors than they did before we implemented this, and our development teams ship more often and with more confidence now, thanks to the progressive deliveries that we've implemented via canary deployments and feature toggles.
Yeah, 100%. Now, canary deployments are a nuanced things, right? As we've learned here, we went in with best intentions, thinking, hey, we'll use these canary rings to sort of try and eke out the problems in our software before they reach the bulk of our customers. The nature of our product means they just didn't work for us. And so we had to retool and sort of refocus on what's really important in our delivery pipeline. So if you are thinking about progressive delivery and canary deployments, think about how they might apply in your particular context and scenario.
Absolutely. I think the point we would make is that canary deployments and feature toggles both have a really important role to play in implementing progressive delivery. They have different strengths and different weaknesses as well. So to get the speed and control, the combination of both is really powerful.
And always make sure to measure if you want to understand what's going on in your delivery pipeline. As I said, we weren't actually clear on what our problem was until we started measuring certain things and came away with insight as to where the problem lay. People were sort of unhappy that the developer experience wasn't great. People were unhappy with lead times, but it wasn't clear where in our whole overall pipeline setup the problems were. And that meant we didn't know what the solutions were too. So most businesses that deal with software have surprisingly complex delivery, continuous delivery needs these days. Deployments are not simple things. And there may be, areas that you can improve where, your current status quo that exist if you just sort of measure what you've got and sort of take stock and see how you're stacking up.
There is no one size fits all for progressive delivery, right?
Nope. Yeah, don't believe what Google and Meta tell you.
The final point here is you've seen us a few times in this presentation refer to Octopus Feature Toggles, and if you're interested in these as a feature, then stay tuned because they're coming as a public alpha early in 2026. So there's a card on our roadmap for this, and if you're interested, please go along and subscribe to that card and register your interest and stay tuned. And with that,
Yeah, we'll toggle the feature on for you.
shipping feature toggles with feature toggles. It's very meta, isn't it?
That's it.
I think with that, we're going to say goodbye, aren't we?
That's it, Mike. Thanks. That was fun.
It was indeed. I hope you enjoy the rest of Shipped, folks. See ya.
See you all.